When you think clean energy, what comes to mind? For a lot of us, it's an image just like this, right? A massive dam. It feels powerful, clean, almost heroic. It's hydropower, this incredible symbol of us taming a river to light up our world.
And for what, a century now? We've looked at dams as these incredible monuments to progress. I mean, they make huge amounts of power from what seems like free fuel, just flowing water. It's such an elegant idea, right? Harnessing a force of nature without burning a single lump of coal.
But you knew there was a but coming. Behind that clean, powerful facade, the story gets a whole lot more complicated. So it really makes you wonder, what is the true price of taming a river?
So let's start with the idea we all kind of have in our heads, that hydropower is the ultimate clean powerhouse. But as we're about to see, that idea might have a few cracks. We're going to start by uncovering the carbon cost, some hidden emissions you probably haven't heard about. Okay, so here's the thing. The electricity itself, yeah, it's carbon-free. The water spins the turbine, and that's that. But that is not the whole story, not by a long shot.
And get this is the real shocker. In some places, especially in the tropics, a hydropower plant can actually pump out more greenhouse gases than a regular old oil-fired power plant. I mean, how is that even possible? Well, the culprit is a gas called methane. See, when you build a dam, you flood a massive area of land. And all that stuff, the trees, the plants, the soil, it all gets submerged. It starts to rot under the water without any oxygen, and that process releases huge amounts of methane.
And methane isn't your average greenhouse gas. Oh no. Over 100 years, it's 34 times more potent at warming the planet than CO2. 34 times. It's basically a climate superpollutant, just bubbling up from the bottom of these man-made lakes.
And what's really fascinating here is that this isn't a slow burn. The effect is totally front-loaded. The science shows that methane production goes into overdrive in the first, say, 6 to 12 years. That's when all that fresh organic material is breaking down super fast. It's like a methane time bomb that detonates right after the dam is finished.
Okay, but it's important to know that not all hydropower is the same. That giant dam we all picture, it's just one type. There are others, and they paint a much more complex picture.
So you basically got two main flavors. First, the big reservoir dam we've been talking about, the kind that blocks the whole river and makes a giant lake. But then you have something called run-of-river, and it works in a totally different way with a much smaller footprint.
So instead of a giant wall, a run-of-river system just diverts some of the water, runs it through a powerhouse to spin a turbine, and then puts it right back in the river downstream. See? No huge reservoir, no drowned forests. It's a way gentler approach to getting power from the river.
But let's go back to those big dams. Their impact goes way beyond just greenhouse gases. We really have to talk about the ecological price of putting a wall in the middle of a river.
I mean, a dam is literally a wall. It stops fish, like salmon, from getting upstream to where they need to spawn. It messes with the water temperature, the flow, and this is a big one. It traps all the nutrient-rich sediment that's supposed to wash downstream. That sediment is what builds and feeds our deltas and beaches. Without it, they literally start to disappear.
So what happens if you take the wall down? Well, we have this incredible story from the Elwha River in Washington. Dams went up back in 1911, and the famous salmon population just collapsed. But then, about a century later, they took the dams out. And guess what? The river came roaring back, the salmon came roaring back. It's this beautiful, powerful example of just how resilient nature can be.
Okay, so after hearing all these problems, methane, ecological damage, you might be thinking, why are we even talking about hydropower anymore? Well, because this old-school tech has a shockingly important role to play in our modern energy grid.
It sounds like a total paradox, but the more solar and wind we put on the grid, the more we actually need hydropower. And the reason why boils down to this one really key concept.
It's called grid inertia. The best way to think about it is like a shock absorber for the power grid. You've got these massive, heavy turbines spinning in a hydro plant, right? They have real physical momentum. That spinning energy acts like a buffer, keeping the whole grid stable when there's a sudden change in power. It's a physical thing, and it's something that solar panels and wind turbines, which are based on electronics, just don't have.
And this chart here really lays it all out. Hydropower, it gives you that physical inertia. Plus, it's dispatchable. That's a fancy word for on demand. You can flip a switch and get power when you need it. It can even do something called a black start, which means it can restart the entire grid after a blackout all by itself. Solar and wind, well, they can't do any of that on their own.
So why is this a big deal? Well, look at what happened in Spain and Portugal back in 2021. Solar was generating over half the power that day. That means the grid had very little of that spinning inertia we talked about. It was fragile. So when one little thing went wrong, it cascaded into a huge problem. It was a perfect and kind of scary reminder of why that stabilizing force from hydro is so vital.
So all of this brings us right to the heart of the matter, the hydropower dilemma. It's an incredibly useful tool, but man, it comes with a heavy price tag.
So you have to weigh the pros and cons, right? On one side, you've got cheap, reliable, on-demand power that provides the stability we desperately need for a renewable future. But on the other side, you've got methane, blocked rivers, and completely upended ecosystems. It is a classic, difficult trade-off, and there is no simple answer.
And believe me, the stakes are incredibly high. The International Energy Agency, the IEA, says that if we're serious about hitting our climate targets, we have to double the amount of hydropower in the world by 2050. Double it, because we need it to balance out all the new solar and wind. So yeah, we're pretty much caught between a rock and a hard place.
And that leaves us with this one giant, lingering question. As we're racing to build this new, clean energy future, how on earth do we balance the undeniable power of the dam with the precious, irreplaceable life of the river? Finding the answer to that is going to define not just our energy future, but the health of the entire planet.